So as Mike said, I'm the functional verification manager for nVidia in Bristol, part of the mobile communications team. So we're actually the old ICERA team. We got bought around a year and so ago now. So I can't speak for nVidia in general. Like many companies, we do a lot of stuff. We've got a lot of teams. So this is kind of specialized to what we do in Bristol, where we design basically processors and SOCs for soft modem DSPs, which are processor-based kind of design. So the first real problem we've had is the software-hardware co-design problem. And the key thing here is actually co-design. So a few people last year mentioned software-hardware co-verification. Now, we find that the boundary between software and hardware is actually softening between firmware, software, middleware, whatever you want to call it now. And as the cost of manufacturing and the cost of designing a new chip is increasing, actually software is quite a good way of getting more lifetime out of a product by doing continual upgrades once you're actually already in the market. So the idea of actually co-verifying the software and the hardware together is a bit more obvious than it used to be. But the real problem there is that you actually need real software in order to verify the real software before you've got real silicon. So if you're lucky, your software team's really busy because that means that your software team is supporting customers and they're doing multiple products and they're continually rolling out new designs all the way through. So encouraging them to actually put the effort in 2, 3, 4 years before they're actually going to make that product can be quite tricky when they've already got their hands full actually designing and maintaining the work they're already doing. We have this particularly as a problem because anyone who watches the news knows in the market, 3G, 4G telephones, networks changing constantly. Each network is doing a different thing to try and get their own niche of the market. So often actually the standard doesn't even exist 4 years before it comes out as people push really quickly. So, and the other disadvantage is actually the most complicated scenarios are often the ones that that are hard to prototype. So you can do modeling, transaction-based approaches, TLM-based approaches, FPGAs, or even emulation. But actually, the really hard bits, like entering, exiting, power down modes, complex clocking, real-time timings against, in our case, network testers, can only be done when you can run at a particular speed and are only useful when you can run on the actual design. The level of abstraction doesn't always find the bugs at the right time. And the real thing here is that actually the biggest benefits you can achieve where you can decide to save the most hardware is when you can do this early in the project and you can trade off software versus hardware. So the earlier you can do this, the better, but the harder it is to do the earlier in the project. So the second point is performance verification. So there's been a lot of changes in functional verification over the last few years. Harry just talked about this for a while. There's been a lot of innovation in UVM, VMM, OVM, AVM, I'm not going to mention more. But the advantage of this is that the problem is kind of understood. As Harry said, we may be doing a bad job of it in many cases, but we actually have a terminology and we have a world of reference that we're all talking the same language and we're all looking for the same thing. Performance verification can really be split into two problems. One is the sort of metrics of performance verification, and the other one is the definition of those performance metrics. At the moment, we certainly struggle to have either. So it's mostly been left to individual teams and companies, even teams within the same company, to define their own metrics and how they're going to approach performance verification. And I said there's no EDO language support to do this. In System Verilog or Specman or anything System C, there is a coverage definition. You can do functional coverage. Code coverage is defined. Usually EDA companies may have their own slight variant on code coverage or statement coverage or whatever they call it themselves. But the general approach is very much the same. We don't have that language for performance verification. And the final part is, as we try to do more flexible chips that can support the very, very high end and chips that can support the very, very low end at maybe different power or cost points, how do you write one performance point that will pass when you're running really fast and you've already turned other things off in order to hit that performance, and get it to pass at the same time when you're deliberately running more things in parallel to try and hit a low performance case? And it's the final slide, which is kind of how to make friends and influence people at a conference. Point out how bad everything is. So anyone that's looked at LinkedIn can tell you that verification engineers are always in demand. Nearly all companies are searching for verification engineers almost constantly. But you would have thought with all the advances in OVM, AVM, UVM, that this kind of standardization where we're all kind of supposed to be singing from the same hymn book, it should be getting easier to recruit people. You should be able to hit the ground running, get someone in, they've worked on UVM, OVM before, show them the test bench spec, 2 days later they'll be writing tests. Doesn't seem to be getting that easy. In fact, it seems to be getting harder. Actually, the fact that some people have been so successful, the EDA companies particularly preaching the merits of methodologies and metrics and everything else, everyone knows the terminologies. Everyone knows what they're meant to do. So actually establishing whether they know what to do in an interview gets harder and harder. So the idea of somebody taking over a test bench and writing 2 more coverage points is quite straightforward. Anyone can do that. You can give them a spec. They'll add 2 extra coverage points for a specific thing. Getting someone to sit down from a blank piece of paper and actually specify what a test bench has to do and know and be able to link all the dots together to actually say that this test bench is capable of saying this design is worthy to ship is actually harder and harder. And part of this problem, at least in my opinion, which is the bit that's really going to annoy people, particularly companies that send contractors in, is that as we outsource verification, and this isn't just outsourced to companies that provide it, but even outsourcing within the same company into specialist verification teams or people that only work on closing verification, people and the sort of rise of VIP in this, the quality of verification is actually abstracted away from the tape out of a chip. So I think there are verification teams that are very good at delivering VIP, but they almost forget that the function of it is to reduce the risk of a tape out of an actual chip. And as you abstract the people further and further away from this ultimate aim, some of the sort of anal checking that you have to do to know that you're right